All right, so have you ever heard of a metal, and this is going to sound weird, but have you ever heard of a metal that melts right in your hand?
Like a magic trick.
Kind of, but it's not a trick. It's science, it's gallium. And that's what we're diving deep into today.
I have to admit, I don't know much about gallium, so I'm excited to hear what you found.
Yeah, me too. And we've got some really cool research papers to dig into.
Sounds good to me. Let's dive in.
So let's imagine we're back in the 1800s with Dmitri Mendeleev. He's putting together the periodic table, right? And he gets to this spot right below aluminum, and there's a gap.
Okay, I'm picturing it. So what did he do? Just leave it blank.
Well, he could have, but Mendeleev, he was a bit bolder. He actually predicted that an element should exist in that spot.
Wow, talk about confidence. So he just guessed an element was missing?
Not just guessed. He used the patterns he was seeing in the periodic table to make an educated prediction. He even went as far as to describe this element's properties. He called it eka-aluminum. Eka meaning one in Sanskrit, so basically one below aluminum.
He named an element that hadn't even been discovered yet. That's impressive.
Yeah, and get this. Our sources detail how he was remarkably accurate. He predicted things like its density, its melting point, even how it would react with certain acids, all based on his understanding of the periodic table.
Wow, so he basically created a roadmap to find this element.
That's a great way to put it, and sure enough, just a few years later in 1875, a French chemist named Paul-Émile Lecoq de Boisbaudin, using a spectroscope, which helps analyze light, he observes two distinct violet lines.
Two violet lines, that's it.
Yeah, but those two lines were a dead giveaway. They indicated the presence of a new element, and guess what? It was eka-aluminum, the element Mendeleev had predicted.
So Mendeleev's predictions about its properties, they were right.
Right on the money. Even a small initial discrepancy with the density was later cleared up. Pretty remarkable, huh?
Absolutely. What a testament to the power of the scientific method and the periodic table.
It really is. But back to gallium. We know it melts in your hand, but what else makes it so unique?
Well, that low melting point, it's only 29.76 degrees Celsius. That's barely above room temperature.
So on a hot day, you can literally melt gallium just by holding it.
Pretty much. It wouldn't take much. But it's not just the low melting point, it's also the huge range between its melting point and its boiling point.
Okay, so how high does it need to get before it boils?
Over 2,000 degrees Celsius, it stays liquid over an incredibly wide range of temperatures.
So it melts easily, but boils like, well, something with a really high boiling point.
Exactly. And there's more. Unlike most substances, which expand when they freeze, gallium actually contracts when it solidifies.
Okay, now that's just weird. So we've got this metal that melts at practically room temperature, shrinks when it freezes. What else?
Well, it also has this unusual ability to float on its own liquid.
It floats on itself. You're kidding.
No, it's true. It's a rare property, but gallium does it.
Okay, so we've established gallium is a very unusual metal, but why? Why is it so weird?
It all comes down to its atomic structure. You see gallium atoms, they like to form pairs. These are called Ga2 dimers.
Giga dimers. Sounds complicated.
Not really. Think of it like this. The gallium atoms are holding hands in pairs, and these pairs, they're not as interested in bonding with other atoms.
So they're kind of like a bunch of exclusive couples at a party.
Uh-huh. Yeah, you could say that. And because they're less interested in bonding with others, they're easier to separate, which is why gallium melts so easily.
So these gallium atoms are holding hands. They're not too keen on mingling with other atoms, and that's why we get a metal that practically melts on contact.
It's a simplified explanation, but you've got the gist of it.
It's amazing how these tiny atomic interactions lead to such unique properties. But this low melting point, while intriguing, makes you wonder, what's the practical use of a metal that melts so easily? So you might think that with a melting point that low, gallium wouldn't be very useful, but actually that's not true at all.
Yeah, you'd be surprised. It's actually used in a lot of important technology.
Really? Like what kind?
Well, have you ever heard of semiconductors?
Oh yeah, those are like the brains of all our electronics.
Right. They're what make all our computers and phones and everything work.
So is gallium used in those?
It is. A lot of semiconductors are actually made with a compound called gallium arsenide, or GaAs.
Gallium arsenide. Okay, so how does that work?
Well, it's kind of complicated, but basically gallium arsenide is really good at converting electricity into light, and vice versa.
Interesting. So like it can create light.
Exactly. That's why it's used in LEDs.
Oh, right, LEDs, like the little lights on our phones and stuff.
Yep, and in those big screens they have at concerts and stadiums, even car headlights are using them more and more.
Wow, so every time I see an LED, there's a good chance there's some gallium in there.
Most likely, yeah. It's even in lasers, like in those barcode scanners at the grocery store.
No way, really. I had no idea gallium was used in so many places.
Oh, yeah. It's way more common than people realize. And remember how we were talking about its wide liquid range? Well, that's really important for electronics, too.
Oh, right, because it can handle high temperatures without, like, melting or boiling over.
Exactly. Gallium arsenide has a really high boiling point, which is why it's used in high-speed electronics.
Oh, I see, so it can keep up with all the data processing and stuff without overheating.
That's the gist of it. They use it to make high-speed logic chips and low-noise amplifiers. It's even used in those 5G towers they're putting up everywhere.
Wow, so gallium's not just in our electronics, it's helping to power the whole network.
Pretty much. And there's another gallium compound that's becoming really important, too. Gallium nitride.
Gallium nitride, what's that used for?
A lot of the same things as gallium arsenide, actually, but it can handle even higher power and frequencies.
Oh, wow, so it's like gallium arsenide on steroids?
Kind of, yeah. It's used in those really powerful LEDs, and it's also what makes blue and green lasers possible.
Wait, blue lasers? I thought lasers were always red or green.
Well, red lasers were the first ones they invented, but now they have them in all sorts of colors. You know those Blu-ray players?
Yeah.
They use blue lasers to read the discs, and those lasers are made with gallium nitride.
That's incredible. So what you're saying is this metal that melts in my hand is also responsible for all the high-def movies I watch.
Pretty much. And that's not even all of it. They're also using gallium nitride in electric car chargers and even some military radar systems.
It's amazing how this one element can be used in so many different ways.
I know, right? And we're not even done yet.
Wait, there's more.
Oh, yeah. Remember how I said gallium was used in a lot of different fields? Well, we've only talked about electronics so far.
Oh, right. I almost forgot. You mentioned something about neutrino detection. What's that all about?
Great. So neutrinos are these tiny subatomic particles that are incredibly hard to detect.
How hard?
Well, they can pass right through the entire Earth without hitting anything.
Seriously.
Seriously, they're like tiny little ghosts.
So how do you even detect something like that?
Well, it takes a really, really big detector, and some of the most sensitive neutrino detectors in the world use tons and tons of liquid gallium.
Tons. We're talking like elephant tons here.
More like blue whale tons. One experiment in Russia uses a detector with over 50 tons of liquid gallium.
That's crazy. Why do they need so much?
Because even though trillions of neutrinos are passing through the detector every second, only a tiny fraction of them will ever actually interact with the gallium.
So it's basically a waiting game.
Pretty much. But when a neutrino does interact with the gallium atom, it creates a tiny flash of light, and that's how they detect it.
That's incredible. So they're using a metal that melts in your hand to study these tiny invisible particles from space.
It's pretty amazing, right? And it doesn't stop there.
Wait, there's even more.
Yep. Gallium is also used in medicine.
Medicine, really?
Yeah, they use it in these things called gallium scans.
Gallium scans, what are those?
It's kind of like an X-ray, but instead of using X-rays, they inject a small amount of radioactive gallium into your bloodstream.
Radioactive gallium. That sounds a little scary.
Don't worry, it's perfectly safe. The amount they use is very small, and it decays quickly.
Okay, that's good to know. But what does the scan actually show?
Well, it turns out that gallium tends to accumulate in areas of inflammation or infection.
Oh, interesting.
Yeah, so if you have an infection somewhere in your body, the gallium will light up on the scan, and doctors can use that to pinpoint the source of the problem.
That's actually really cool. So gallium is like a tiny little detective sniffing out infections in the body.
That's a great way to put it. And they're even doing research into using gallium compounds to fight cancer.
Wow, really? How does that work?
Well, it's still in the early stages, but some gallium compounds seem to be able to disrupt tumor growth.
That's incredible. So this one element could potentially help us fight cancer, understand the universe, and power our smartphones.
It's pretty amazing, isn't it? Who knew that something that melts in your hand could be so versatile?
I know, right?
Yeah.
It just goes to show that there's so much more to the world than meets the eye.
Exactly. And it makes you wonder what other hidden potential is out there just waiting to be discovered.
That's a great question. But before we get too philosophical, we should probably talk about something a little less exciting. The supply of gallium.
Oh, right. That is important. Unfortunately, it's not as simple as just digging up a bunch of gallium whenever we need more.
Oh, how come?
Well, gallium is actually a byproduct of aluminum and zinc mining.
A byproduct? What does that mean?
It means that we don't actually mine for gallium directly. Instead, we extract it from the waste products of aluminum and zinc mining.
Oh, I see. So our supply of gallium is dependent on how much aluminum and zinc we're mining.
Exactly. And as demand for gallium continues to increase, that could become a problem.
You mean we could run out?
It's possible. There are only so many places in the world where they mine aluminum and zinc, and those mines only produce a limited amount of gallium each year.
So what happens if demand outstrips supply?
Well, the price of gallium would likely go up, and if it gets too expensive, it could slow down the development of new technologies that rely on it.
That's not good. So what can we do about it?
Well, there are a few things. One is to improve the efficiency of gallium extraction, so we can get more of it from the same amount of ore.
That makes sense.
And another is to start recycling gallium from electronic waste.
Oh, right, because all those old phones and computers probably have gallium in them.
Exactly. If we could find a way to efficiently recycle all that gallium, it would go a long way toward meeting future demand.
That's a great idea. Are there any companies or researchers working on that?
Definitely. It's becoming a big area of research, and there are already some promising technologies being developed.
That's good news. So it sounds like the future of gallium is kind of a mixed bag. On the one hand, it has the potential to revolutionize everything from medicine to energy production. But on the other hand, we need to be careful to use it sustainably so we don't run out.
Exactly. It's a delicate balancing act, but I'm confident that we can find a way to make it work.
I hope so. Well, I don't know about you, but I've learned a lot about gallium today. I had no idea this metal that melts in your hand was so important.
Me neither. It just goes to show that even the most unassuming elements can have a huge impact on our lives.
It makes you wonder what other secrets are hidden in the periodic table, right?
Yeah.
So we've talked about how gallium went from like this theoretical element to something that's in basically every smartphone.
Yeah, it's pretty wild.
It is. But what's next for gallium? I mean, where is all this research headed?
Well, one area that's super interesting is flexible electronics.
Flexible electronics. Okay, so we're talking like bendable phones and stuff.
Exactly. Imagine phones that fold up or displays that you can, like, wrap around your wrist.
That'd be so cool. But how's gallium going to make that happen?
Well, remember how we talked about its low melting point and how it can wet certain materials?
Yeah.
Those properties make it perfect for creating, like, the really thin, bendable circuits they need for that kind of technology.
Oh, I see. So it's not just about making the devices themselves bendable. It's about making the electronics inside bendable, too.
Exactly. And because gallium's so good at conducting electricity, it's a really promising material for this kind of thing.
So we could be seeing gallium in, like, foldable phones and flexible screens in the future.
Definitely. It's already being used in some prototypes, and I think it has the potential to really revolutionize the way we interact with technology.
I can't wait to see it. What else is next for gallium? Anything else cool in the works?
Well, this might seem like a bit of a jump, but there's also a lot of interest in using gallium for carbon capture.
Carbon capture, wait, like fighting climate change?
Exactly. You see, some of those gallium alloys that are liquid at room temperature, like Gallium, they're actually really good at absorbing carbon dioxide.
Oh, right, Gallium. That was the one that could be used in thermometers instead of mercury.
That's the one. And researchers are now figuring out ways to use those liquid alloys to pull carbon dioxide right out of the air.
Wow, so the element that melts in your hand could help save the planet. That's amazing.
It is pretty incredible, right?
It really is. We've covered so much in this deep dive. It's mind-blowing to think that a single element can have such a huge impact on our lives.
I know, right? From Mendeleev predicting its existence to it being in basically every piece of tech we use, it's been quite a journey.
It really has. And it makes you realize that there's so much more to the world than we often think about, right?
Absolutely. There's so much we still don't know, but that's what makes science so exciting.
It really is. So to everyone listening, next time you pick up your phone, just remember that there's a little bit of melts in your hand wonder tucked away inside, making it all possible. Thanks for joining us for another deep dive. See you next time.